Well, good morning, afternoon, evening, night, I suppose, whatever the time of day it is, wherever you may be. Thanks so much for joining me anywhere from where you may be across the world. Let us know where you're joining us from. We're here live on Serverless Office Hours today, streaming on the AWS Twitch channel, on YouTube, Serverless Land, and also LinkedIn Live. So wherever you're joining us, thank you so much for being part of today's stream. My name's Julian Wood. I'm a developer advocate along the Serverless team, and I have a collection of the greats who are going to be talking today. First up, Tim. Tim, you're a networking solutions architect, and despite your accent, I know you're in California. How are you, and what has your journey been like to get to AWS and what you're doing today?
So my journey to AWS, I've been doing networking for longer than I like to admit.
My condolences.
Yeah, sometimes it's a good thing, but sometimes I'm starting to get embarrassed about the amount of years I've got in networking. Anyway, so I worked at Cisco for many years. Before that, I worked at Nortel. That's giving you an idea of how far back I go. And then I wanted to get out of doing networking, so I tried to get more involved in sort of cloud and software and containers and all that kind of stuff. And I've been at AWS now for about 2 years, just over.
Cool. So you decided you wanted to leave that networking, and then you discovered that the cloud is actually all networking, a lot of networking just in another place. So sorry for the wake-up call. Yeah. And Nipun, you're also in California, I know. So yeah, you're part of the digital native business. That sounds like a cool title. What does that mean?
Yeah. Hi everyone. So I've been with AWS for a little over 6 years now. I started as a technical account manager, and then my passion and drive led me to the transition into this role as a solutions architect, primarily focused in the Bay Area digital native customers, which are like the Ubers and Lyfts kind of for customers who are building a lot of their modern applications within the AWS. So I help these customers to be successful using the AWS platform.
Fantastic. And just to say, before we get to Josh, who is also a solutions architect, I know, despite his much better serverless title. But yeah, solutions architects, in my opinion, are some of the amazing people at AWS who literally speak to customers all day, every day, and help them with some of the easy problems and some of their harder problems. So yeah, whenever you see solutions architect, big job at AWS. And yeah, Josh, you're the tech lead for serverless at AWS. I know you've got a big role. You, in fact, look after a huge amount of other solutions architects and specialists looking after serverless. What's your AWS journey?
So I've been at AWS now for 7+ years. I'm based in Chicago. And yeah, my role is I do some specialist SA stuff with serverless. We have a 1,000-person strong community of experts in AWS. And now it's just about that time of year where my entire role becomes planning reInvent, even though it's 180 some days out.
I was going to say, I'm pretty sure you know the exact number of days out, but yeah, Josh is the tech lead. You know, he sort of corrals 1,000 people who are doing a whole bunch of serverless stuff, and also is hugely involved in putting on the serverless track at reInvent. So yeah, it is weird that we're all thinking about what's going to happen at reInvent. So mark that on your diaries. Sorry for our American colleagues. It's probably one of the bad times of the year just after Thanksgiving, but sometimes it's just going to help you get out and about and learn some tech. So yeah, reInvent on your diary for the end of the year. Well, thanks, Josh. Before we get onto that, let's just look at the last week of serverless. If I jumped too many slides, yeah, the previous stream, 23rd of May, this is really cool, all about using Amazon Code Catalyst, and this was a service announced at reInvent, which James, Doug, and Ryan all went through, and it's actually a sort of different way to build applications on AWS, connecting a whole bunch of different services, AWS ones, and in connectivity to other third-party services. So yeah, Code Catalyst is a super good service, interesting service to go and have a look at. And all of these and all other streams we've done is on the YouTube Serverless Land channel. So go and have a look at those. Then in terms of what's new with AWS Serverless, a couple of things. People who love Cognito, for some of you, there is a new console experience, and Cognito I know is a little bit sometimes difficult. People I know tell us, but it's super powerful, and it really does a whole bunch of things. And the Cognito team have been hard at work improving the console experience for identity pools just to make things a bit more intuitive, which I know will be music to some people's ears. Then second one, we've got AppSync, which has merged APIs for GraphQL Federation. And next week, we will actually have people from the AppSync team talking about that and new AppSync releases. So yeah, AppSync using GraphQL. This is really cool that you're going to be able to have a single API endpoint coming in and then merging APIs behind the scenes, which is really, really good. And then just to skip quickly over Amplify, nothing against Amplify, but there is a new authenticated UI. But Amazon EventBridge has improved end-to-end latencies for Amazon EventBridge event buses. And this is one of those things where we do actually have a few customers who call up our support line and go, I think something is wrong. EventBridge got faster. And we'd reduced latency by something like 80%. And customers do wake up and some alarms do go off, and I am being slightly jokey, but this is one of the benefits of using serverless. Behind the scenes, things just get better, bigger, faster, and more. And yeah, a big chunk of latency removed from EventBridge if you're using that. So I hope you woke up one day and were pleasantly surprised how EventBridge is evolving. There are some blog posts. Sometimes they're related to the releases, sometimes not. The top one is interesting. A serverless Slack app using step functions and Lambda. And this is really cool, where you can have a Slack workspace and you can just use a bot within the workspace, and that can then go and automatically kick off the step functions workflow to do whatever you want to do and come back and reply within your Slack channel. So really sort of nice, tight integration for your developers, where they don't then have to go to the AWS console or even know that exists to do step functions. They can do a whole sort of a chat kind of thing within Slack. And yes, Sam and John have done a really good use case for that. And then just third one down, also X-Ray. Anybody developing service applications, they are distributed. Tracing is really important and really helps you out. And really good to have active tracing for SNS, which I'm sure is going to help out a lot of people. But on to this week, we are talking serverless networking with VPC Lattice. And Tim talked about his history, or my history is an infrastructure person as well. And I have not done as deep in the weeds as Tim with networking, but I've certainly done my fair share of routing and switching and firewall rules and all that kind of thing from an infrastructure and service perspective. And one of the things I absolutely love about serverless, the whole ecosystem, is actually how much networking is abstracted from you. I think lots of people get all caught up in the microservices and the functions as a service and everything, but actually the networking part, what serverless takes away, is really beneficial. However, there's a lot of networking still out there, and anyone doing VPCs with AWS knows there's a bunch of configuration to do. So, Tim, can you tell us about VPC Lattice, which is all about making networking easy and can be used with Lambda as well?
Yes, I can. I'm just going to share some slides. So let me share my screen.
Oh, and while Tim is bringing up his slides, don't forget we are live on Serverless Office Hours. I'm tripping over my brain today. So please send us your questions, send us your comments, even let us know where you're from, and we'd love to help you out if we can. We already do have a fan from Sean Knowles. Josh, I am your biggest fan. So thank you, Sean, for joining us via YouTube. But yeah, send us your questions if you do. Over to you, Tim.
Okay, you can hear me?
Yes, we can.
Just making sure, because I've got a bit of a cough, so I keep muting myself, and I'm one of those people that tends to talk on mute. So if you don't hear me, let me know. So just starting off, what is VPC Lattice, or what is the intent? Why did AWS develop VPC Lattice? And it's really focusing on the simplicity to developers. This was the initial mission statement for VPC Lattice. How do we make it simple for developers to connect, secure, and monitor their services without sacrificing the controls admins need to audit and secure their environments? So what we're trying to do is make it really simple, yet without sacrificing any of the security or any of the components that are very important to us as businesses, or as developers for businesses. And when we look at traditional networking, and this is intended to be a very busy slide, and it's stolen from a reInvent video a couple of years ago, but there are so many different components within the networking, and they're all intended to make life easier. But when you just see them, it becomes quite a daunting experience, or quite a large task on how to make all of your different products communicate with each other. So what we're trying to do with VPC Lattice, or what we do with VPC Lattice, is you don't have to worry about any of this. We're just making it very simple for you to connect from a service in one VPC to a service in another VPC without having to get involved in any of the route tables, any of the IP addressing. One of the really cool things that VPC Lattice does give you is that if you've got overlapping IP address ranges in different VPCs and you still need services to talk to each other, you don't need to worry about it with VPC Lattice. We can do that. And I know that that's a fairly common problem, particularly with companies that have merged or been acquired and so on and so forth. So just stepping through what the different components are. We've got services in 2 different VPCs. Today, how do we make them talk to each other, or how do we enable them to communicate? We can use internet gateways, we can use transit gateways, we can do VPC peering, and we can do private link. And all of these take some networking knowledge about the route tables and the other components. The second part is that we've seen a lot more customers using VPCs as boundaries. And I know this doesn't work as much within the serverless world, but when you've got to go across to services that are perhaps still hosted on EC2 or things that are on Kubernetes or ECS, we still need to make sure that they all communicate with each other securely and easily. And how do we manage all the different parts? How do we do the service discovery, the traffic management, load balancing, and all of these different things, make sure that things are secure. And this is really where VPC Lattice comes in. If we look at a traditional setup of how we would create this, we might have some services behind an application load balancer. We need to put things into DNS. We need to ensure that all the networking communications or connectivity between these 2 VPCs are in place. And this is really the problem that VPC Lattice was designed to address. And the way that we address that, and I'm going to kind of start to talk about different parts of VPC Lattice, rather than worrying about all the different routes or the communications or how things work, VPC Lattice, as the name suggests, creates connectivity between the VPCs. And we're very focused on these 4 pillars. We create a service from whatever your application, whether it's a Lambda function or so on and so forth. We create a service. And then we can publish this service into a service network. And what that allows us to do is create a different boundary from the VPCs or from any of the other networking constructs in AWS, where we can access those services. So we create a service, we publish it into a service network. And then from a consumer standpoint, if they're in a VPC, we attach that VPC to the service network. And as long as all the policies are available or are permitting, anything within that VPC can access that service. Now, we can do a bunch of things with the security policies, not just restrict who has access, but we can also start to put policies about the access methods. So we could impose it has to be get and we can't do post and things like that. And then there's a service directory. And I'm mindful not to be doing too many slides because I think seeing how it works is a lot more important. So hopefully I'm just kind of framing this up. So here we have a service VPC, and we could have an application load a auto scaling group with EC2 instances behind it. We could have Lambda functions. We could have ECS and EKS. Throughout my demos, I'm going to be in a separate VPC to access whatever we create as a Lattice service, a VPC Lattice service, and running Cloud9, which is hosted on an EC2 instance that sits inside a VPC. And I'll show you the user policy that I have, or the assumed role that I'm using from the client. And then they could reside in the same AWS account. We can share these services across accounts using Resource Access Manager. One of the really nice things about VPC Lattice is it leverages a lot of the things that we already have at AWS. We don't reinvent the wheel. So where we've got things like Resource Access Manager, and we want to share across accounts, we use Resource Access Manager because it's simple and a lot of people have been using it for a while. So the things that we're going to go through and in the demo we're going to create is we're going to create a target group. And this is really the end application of access, whether it's the individual So if it's Kubernetes and you've got your cluster and you've got all the nodes, and then you have the pods, each pod will have an individual IP address, and those pods will become the target of the target group. So we can be very explicit on where we forward the traffic. Same with EC2 behind an autoscaling group. We direct to the individual IP addresses of the EC2 instances. And in Lambda, we can create target groups of the Lambda functions, and we'll do an example of that. When we take a Lambda function, we put it behind an API gateway, and we want to make that create a private API, and we want to make it available within a VPC. We'll typically use a VPC endpoint to access that. And that VPC endpoint will get an IP address. And when we try to access it, we use the private DNS, and then we access that IP address, and it goes across AWS infrastructure to the Lambda function itself. One of the cool things that we do with VPC Lattice is that we don't give a real IP address to the service. We use these linked local addresses. And a linked local address is, you might see these addresses, these 169.254 addresses, if you, back in the day when you plugged your laptop into a wired network and you didn't get a real IP address and you ended up getting one of these 169.254s. It's often a sign that your DHCP server wasn't working. And they're used in this auto configuration mode quite often for a number of different operating systems that would allow you to network without some networking resources. We use them at AWS for a bunch of things. 169.254, 169.254 is where you get the metadata of an EC2 instance. But we use them also within VPC Lattice to simplify accessing services. Now, link local, they're non-routable. They're not guaranteed that they'll be unique across network segments. But we just use them because they're convenient, and they're not going to be used for other things. People don't set up VPCs using these addresses. And then also in the IPv4 world, there's a unique local address. The other cool thing about these is that they're not private DNS entries. When we create a service, it will dynamically create a DNS entry, and it's a global DNS entry. So you don't have to worry about where it's accessible from. It's globally accessible, and you'll access it.
So you don't have to then think about, whether it's local DNS or private DNS or public DNS and all that kind of decision-making thing. That's just another complication. If there's anything wrong, it's probably going to be DNS.
Yes, and because this address is only, it's non-routable. There's no security risk with it. It's one of these addresses that really is meaningless unless you're in the VPC, where which is connected to the service network that has the service in. And we don't just use the IP address to forward traffic. We're also looking at the header information. One thing that I didn't mention is that VPC Lattice is a regional service, so it operates in a single region, in multiple regions, but just it doesn't go across region. And it supports HTTP, HTTPS, and gRPC. So I thought I should mention those.
But even as somebody using serverless, right? We don't work with VPCs all that often. A lot of the things that Tim mentioned are fairly transparent with Lattice. When you go in and associate your VPC with a service network, it goes and does all that DNS magic for you and creates that link local address. So then when you associate a Lambda function that's going to call that service, and Tim will show that in a little bit, it will inherit those DNS settings and be able to call the DNS name, and it will resolve. There's no Route 53, nothing that you need to touch in that regard.
It's even more simple. Tim, another question I was thinking of, some people are also starting to build service meshes and all that kind of construct very much in the container world. How does VP Lattice play with that? Or, because we have app mesh and we have different AWS service meshes and even Cloud Map for service discovery. How does this play, or how should people think about Lattice in comparison to those?
Yeah, so we heard from a lot of customers, particularly in the EKS world, where there's a lot of parts of the service mesh that they really want to leverage, but they don't necessarily want to go through the maintenance. You have to inject a sidecar into your pod that will pick up the traffic. You have to go through like the software releases and maintenance and upgrades. And they might not necessarily want all the features. They might perhaps just want some of those features. Now, VPC Lattice is very focused on the networking portion, and it kind of has quite a lot of overlap with the service mesh. But rather than at the edge of a pod or part of the compute, it's at the edge of the VPC. So it does all of the VPC networking as you could do in a service mesh, but it does it as part of the AWS infrastructure. And if I were to use service mesh to go across clusters in different VPCs, which is possible, I can configure all the service mesh to do a similar thing, but I still have to take care of the networking of how the two VPCs talk to each other. So I'd still need a transit gateway or other things. So where VPC Lattice really simplifies that networking portion, a service mesh can simplify it to the application, but you still have to kind of build infrastructure and maintain that infrastructure around it.
And then for people who ask, is this an overlay? Is it an overlay networking or an abstraction of VPCs itself? How would you think about that?
Yeah, it's an abstraction. I mean, it's not an overlay in that we give you this link local address where you access it, but then we kind of go through it. Let me just click through some of these slides, and I'll come back to that question as I go through like the step through. So we have the target group, we create a Lattice service, and then we publish it into a service network, which is the logical sort of network that we can attach all the different VPCs to. And then we publish those services into the service network, and got here an SL for serverless land. And then we attach a consumer side of a VPC. So this could be a Lambda function, and I know that wouldn't reside in a VPC, but it could be attached to a service network. And this could be a private API that we can make accessible to multiple different VPCs of whatever's happening there. And again, we could do this across accounts using RAM. So this could be consumers, this could be your vendors or clients across accounts. So to come back to your question, Julian, I'll just step through here. So the consumer side, and there's a service that I would like to access. And the first thing that we would do is do a DNS lookup. And this is, it'll be my service, blah, 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 and it will have a bunch of VPC Lattice and so on. This is an auto-generated DNS entry. And once the client has that, when they try to access, it'll resolve to one of these link local addresses. When they access that, it'll go straight to that address. It'll get picked up. We update, we put a route in the route table. You don't need to, it's not something a customer would manage. It's just that the client would know how to get there. The client would send the traffic to that link local address. And then this is kind of where the magic starts to happen. We would check if you've got permissions or IAM policies put onto that service. We would check the role of the client. We would check the policies. And if everything, lines up and everything is matched, we basically send the traffic directly over the AWS infrastructure explicitly to the endpoint, whatever that endpoint is. And it's the same access method across all the different compute that we have in AWS. So the question you kind of asked me about that, like, how does it work? Does that answer it?
Yeah, I think so. I think it's just trying to, myself and people picture in their heads the sort of, the inbound side to Lambda and then the outbound side, because they, very different constructs of it, and where it just fits in from a networking space. So in a way, are you saying that the inbound to Lambda would be via a private API, via API gateway, or is there an inbound to a Lambda function which somehow does something different via, to the Lambda API itself?
Yeah. So if someone else can say.
Yeah, so VPC Lattice is another trigger for Lambda, essentially, right? So when you go and associate a service with a Lambda function as its target group, you're creating a resource policy on that Lambda function that essentially allows VPC Lattice to trigger the function or invoke it. So if you go into the AWS console, you'll actually see now VPC Lattice is one of the kind of pre-fill
options,
triggers, and then it will create that resource policy automatically. Or you could, of course, create this in infrastructure as code. One thing I do want to throw out too, before we leave this slide with the whole client and service thing, the client, if you have two Lambda functions, one is the client calling a VPC Lattice service, and the other one is the actual target group. The client calling the service does need to be associated with the VPC, right? Because it needs to be able to get to that link local address. But the target group Lambda, the one that doesn't actually need to, the one that's actually fulfilling the request, does not need to be in a VPC. So you could associate with the VPC, but you don't need to because it's just following those same invoke semantics that Lambda always follows.
So this would then also be a cool use case of you have a service in a VPC that would no longer need then a VPC endpoint for Lambda to be able to get to Lambda. It can just do it via VPC Lattice.
And that's actually one of the things I like most about VPC Lattice is you don't need to know what your downstream, what your service downstream service is. It could be Lambda, it could be Kubernetes, it could be an EC2 instance. It doesn't matter as long as it speaks HTTP, HTTPS. You can make a request to it. You don't need to know anything about the semantics. We'll talk about gRPC maybe a little bit later. There's some other considerations there, but HTTP, you're good to go.
Cool. So yeah, so you just in effect connecting to this abstracted network, and in fact you may not even know. Well, you probably won't know what the end target is. It could be another Lambda function, could be something on EC2, Kubernetes or container, and your source, whatever's generating your source traffic or your client, just doesn't need to know, and so much less networking then to set up because it doesn't need to know where it needs to go or the difference, whether it needs to a Lambda function or EKS, VPC, non-VPC, just symbols.
Exactly.
Yeah, I think especially with the sidecars, with the service mesh, I think it simplifies a lot of that management overhead, and also works well with as customers go across accounts and VPCs. It kind of simplifies that part.
Yeah, definitely. So this is not also then just VPC to VPC connectivity within the same account. This is taking it across any kind of account. You're just doing basically resource-based permissioning, and off you go. We're not having to set up these transit gateways to connect your account to my account and do all of that connectivity and everything. You can just create this fabric, I suppose, and off you go.
Yeah, for east-west communication, it's fantastic, right? Because you can use something like API Gateway or AppSync. Yep, so Sabah hit it on the head, right? This is all about east-west communication. API Gateway, AppSync kind of for the entry point north-south, and then VPC Lattice for the east-west.
Cool. And Nipun, from the customers you're speaking to, when you're mentioning about service meshes and sidecars, there's a lot of networking to talk about there, because you've got the networking, which I know is simplified between the sidecar and your service. But then there's also the networking to the outside world, and then Lambda doesn't really have sidecars in the same way,
right.
And so you've always got to make a different choice depending on the service you're gonna have to think about, and whether that service is Kubernetes based or other container based things. Lots of decisions to make. Nipun, do you think is this the sort of removing some of those decisions that customers need to think about?
Absolutely right. So especially with my customers, they have about 40 to 50 accounts, and with multiple VPCs, managing all that is a pain. And with VPC Lattice going across all these and helping the developers not really think about this whole network constructs and how do I build this, kind of simplifies that. And with my customers having primarily on Kubernetes, and they also have Lambdas, I think it kind of plays well with both these from an east-west traffic. And this is why, again, the API gateway, like what Josh mentioned, API gateway will be the north-south versus VPC Lattice is going to be mainly for the east-west traffic, kind of plays well together.
Okay.
When you're looking from a serverless standpoint.
And one of the things as well, when I create a service network, I can publish a whole bunch of services into that service network, and then I can attach multiple VPCs to that service network. Now, a VPC attaches to a single service network, but I can put services into multiple service networks. So I can create different service networks of different requirements and attach the applicable service network to an individual VPC. But as I scale to multiple VPCs that have a common requirement, it's very simple for me just to add them to an existing service network that has everything they need.
And I suppose that, in a way, there is some sort of mental complexity. It's an additional construct, but then also you are able to, if you think of microservices design and domains and all these kind of things, people can think about their connectivity in a similar way to the way they architecture their application, rather than this whole different networking construct, which may be completely different. And I suppose that's also the other point, that often many companies have a central network team who handle all the VPCs and all that access. And this is a way where those central network teams can, provide maybe some, VPC Lattice guardrails, and then allow developers to create the connectivity between their different services without having to file a huge bunch of tickets to the VPC controllers.
Exactly. So would you like to see it work?
Always would love to see it work. Yes.
So let's get rid of the slides.
There was just a question that came in from Sabia. Thanks for the question before. Thanks for joining us via YouTube. Do we need to use a cloud map for ephemeral things like containers that come and go, so they can be registered with VPC Lattice? Who takes care of the registering, updating their presence? So I suppose that's the service discovery question.
Yeah, well, it's so when you have an ALB, there's an ALB controller. So if you've got Kubernetes and you scale your deployment out, or you scale it in, or your pods start to be unresponsive and you spawn new ones, the ALB controller always updates the ALB, right, of the target endpoints that you have. And in exactly the same way with VPC Lattice, we have controllers in Kubernetes, and it does all the housekeeping. From a Kubernetes perspective, and I'm not going to do a lot on Kubernetes today, we did containers on the couch a couple of weeks ago, so there is a session on that if anybody would like to know a little bit more about containers side. But the controller does all like the housekeeping for the number of endpoints or the pods that need to be updated as targets. But it also allows you to provision the whole of VPC Lattice through YAML files, which is what you need in a Kubernetes world. With the one exception is we don't have the IAM policies in YAML files. But anyway, so let me just share a screen. And if I go full screen, sometimes my tabs go missing, but we can see the tabs. All right, so basically we've got console home here with a bunch of different things. And I already opened tabs at the top just so I can get to them quickly. So if we go to the VPC main dashboards everybody's familiar with, if you scroll down on the bar on the left, you'll see that we've got this new VPC Lattice section. The getting started section, most people don't go and create services from here. They kind of jump into the individual bits. But the nice thing about here is that it has a lot of the information that you might want to start to dive into. There's the pricing details. It's a flat price. There's no AZ pricing or anything. It's just a flat price for everything going across. And there is cost to it. But if you compare it to things like if you didn't have it and you were going across transit gateways and other things, there's also a cost to say. So anyway, all the pricing details are in here if you want to dive into your use case and figure that part out. There's also the user guides and the API reference and so on and so forth. So the reason I'm pointing this bit out is that it's a great place to get information quite quickly when you start having a look at VPC Lattice. So going through the different parts, this is the target group, service and service networks that we kind of talked about. So the first thing I'm going to do is I'm going to create a target group. And before we got on today, I deleted everything out, so it's nice and clean. So if I go to target groups and I go to create a target group, we have a bunch of different options of what we can have for targets. We could do explicit IP addresses of things that could be anything. Instances for EC2 instances, application load balancers, but we're going to go to this one, Lambda function. Now,
Tim, do you mind just zooming in slightly? I know it's not too much to read on the screen, but it'll make it just a little bit easier to read on the people on smaller screens. Thank you.
Is that good?
I think that's certainly better. Thanks.
I do want to point out too, just while Tim coughs again, is we'd be remiss not to point out that the Lambda team also added support for aspects of this in the Lambda console itself, right? So you can go to the configuration tab and triggers and go do all of this work there, except for creating the service network, which Tim will get to in a little bit.
Yeah, I apologize for the cough. Children, and it's one of the.
It's that time of year.
It seems it's always that time of year. Anyway, so go into the Lambda function. We give it a name. We'll call it. I've got one called health, or a Lambda function called health. So I'll just call it health target group. Obviously, it's just a text field. Call it whatever you like. And then I can select from my drop-down list, which is easy for me because I've only got a couple. But you can also do arms and stuff. I'm going to go down here, and there's not a lot to do, right? I've just selected a Lambda function and made it a target, and then I'm going to create a target group. And
but you can also select versions and aliases as well.
Yeah.
Mm-hmm. Yep. Yeah. So yes, so I've just got $latest, so it would just pick up whatever you put as the latest. All right. So now we've got a target group. So I just come back down here and you see that we've got a target group. The next thing is I need to create a service. So I go into the service and then create a service. We're going to call it health. Let's see. And we give it some other things now. Just looking at checking on the time. I'm going to go ahead and I'm going to create with a custom configuration as we go through, just because I think that's kind of cool. So if we go and specify a domain during configuration, and we'll call it health, and I've got a domain already set up, and we'll say that we'll create this custom domain. And obviously, if we're going to do HTTPS, we're going to need a certificate. And just for my demo account, in ACM, I created a wildcard to match the domain, so I can use it for anything. But you might want to tie that down a bit more explicit. I'm going to leave IAM policy out for now. We'll come back after we've done the initial setup, and we'll put an IAM policy on it because it's really powerful and it uses the SIG v4 that we use at AWS. And then I'm going to click on next. Add a listener, HTTPS 443. Now, this next bit is pretty cool. I mean, it's very, if you've used LBs and things like that, it's very familiar. I only have one target right now, so we're going to do 100%. But we have the options to do like canary testing if you had a different part of your application. You could do through here. You could do, perhaps if you were moving from EC2 into Lambda and you wanted to canary test that, you can do that here. We can also do path routing and things like that to multiple different backend services, should we wish to. So there's a lot of intelligence that you can put into the Lambda service itself you want to do for the target groups. But we'll leave it to there for now.
So just thinking, I suppose, from the Lambda point of view, when what Josh brought up earlier about the versions and aliases, you could actually safely roll out multiple versions of your Lambda function and cleverly do a percentage of your traffic to one, check everything's going okay, and so within your whole networking construct.
Yeah, we lost you a little bit there, Julian, or at least I did. I'm not sure.
Sorry.
But yes, you could explicitly call out target groups of different versions, and you could canary test it in VPC Lattice. I don't have any service networks right now, so we can't join one. But if you did, you'd have a whole list of them. And then click on next. And I'm just going to go.
So Tim, I'll be honest, and I'll float a question to you here. When I've played around with this and built some demos and wrote the blog post on it, it wasn't clear to me. Should I start with service or start with service network, or does it not matter? Because like they seem to want to go like this.
Yeah, it doesn't matter. When you delete things out, you can't delete the service that is associated to a service network. It's got like those safety checks. So when you're cleaning it up, you need to make sure that you do it in the order so you don't trip yourself over. So you have to disassociate from your service network, your services. You have to disassociate your service from the target groups from the service. And then before you delete the target groups, you have to deregister the Lambda function or whatever it is before you, a whole bunch of safety checks. And there's the there was a design consideration around resource access manager that if you shared a resource via RAM and the far side was using it, and then somebody went into RAM and deleted it, should you delete this remote side? And it was decided that that was could be dangerous. So if you want to delete a service, you have to explicitly delete the resource share, then go in and delete this that have been, they'll continue to work. And as I said, that was a design consideration. So we can see that we've got a service now, it's active. We've got a domain name here, which is the auto-generated one. I'm just going to copy that to my clipboard. We've got the custom domain here that was created, and there's the certificate that we're using now. If you use a custom domain, you do have to use a certificate that you manage. If you're going to just use the auto-generated one, we look after the certificates. You don't have to worry about the certificates. And it's telling here that we have to go and do the CNAME, so I'll just do that in a minute. And then we're not associated with any service networks. So let's go and create a service network. Service networks, create service network.
And a service network is just a collection of services, essentially, and you associate the VPC with the service network.
Mm-hmm. So create my service network, and then I can associate services from the drop-down list, or I can go and add them later. We'll just do it easy because it's here. And then we can add a VPC association. I'm going to leave this one because these are both the same, but we'll just do it when it's created, and I can just show you the other place that we can do it. Again, so we can put IAM policies onto, and we can put IAM policies on the service itself. So we could have quite a broad policy on the service network, like you need to be authenticated. And then we can have quite an explicit or quite granular IAM policy on the actual service itself to define which VPC in that service, in that account can access it, or in that or which subnet. There's a whole list of different parameters that we can put in. So I'm going to go ahead and create the service network, and then go to the service network. So here's the service network, and it's got the service associated to it, the one that we put in, but we don't have any VPC associations. And you can see it's creating in process, but I'm going to go to the VPC associations. Now I need to add the VPC, the client VPC, to here so I can access it. So I'm going to click on client VPCs and then create VPC association. And again, there's APIs for all this. You don't have to do it all in the console. So my Cloud 9 VPC is where my Cloud 9 client is. And then I can apply a security group. So one of the things that we have to make sure that we do, and this is probably going to be when we're going to consume a VPC Lattice service from a client side, we need to make sure that we allow the 169.254 addresses. And there is a prefix list that allows this. So I'm going to show you that actually, because it's important if anybody's going to try this at home. All right, so we've created VPC association, create in progress, and that one should be healthy now, good and active. So while that's in process, let me just go to Cloud 9. If you go to Cloud 9, I think it's, if I go here, I can go to manage EC2 instance. So I'm just going to click on there. And if I go into the instance, go to security, you can see I've got the security groups and inbound, edit inbound rules. And see this one here, it's PL, that's a prefix list. And just to show you where the prefix lists are, if you come back to your VPC dashboard and you go to manage prefix lists, there's a whole bunch of different ones here. And it was the 009, which is the VPC Lattice, and it gives this range. Now, you could manually put this in and just do an allow traffic from this. But the nice idea about the prefix list is if anything changes, maybe we add an extra range here, it will just automatically get done. So it's good practice to use the prefix lists. Okay, so let's go and update Rack 53 with that DNS name that we captured. That looks a little bit small, so let's just make that a little bit bigger. So I've got a hosted zone. Click on the hosted zone. This is my demo one, and I'm going to create a record. And the record I'm going to create, it's going to be a CNAME, and we're going to call it health because that's what we configured. And then basically all I have to do is put that DNS entry in here. So it's very simple to put a custom DNS to my Lattice service, and then I'm going to create that record.
And good work on, I suppose, early doors getting the VPC-lattice.com. Not nice for the demos. I like it.
Yeah, so I've been doing this job for like a little over 6 months now, and the first thing I did was go and look for a domain to register, and that was VPC without the hyphen was already taken, I think. So I don't know who's got that. But,
wow.
And Lattice was already taken. I mean, I tried, but okay. So let's go to the console and do a curl. Right, so we should just be able to access that service by curling HTTPS. And it's still in my clipboard, I've still got that long DNS, so I'm just going to put the long DNS in. And you can see I've got /health, and that's all my Lambda function does. It just comes back and says /health.
So this is going from an EC2 instance in one VPC across VP Lattice to a Lambda function that's not connected to another VPC, but it doesn't need to anyway, and the trigger for the Lambda function is the VPC Lattice connection or service.
Yeah, I'm just going to put on the screen. So
and just note too that EC2 instance that's hosting Cloud9 does not have IAM permissions, right? To invoke the function, it's not using the AWS SDK. It's just curl.
Yeah, and I haven't put any policy on yet, so
right.
It's just cool. So let's just try the custom DNS that we added. So if we put health, and you see that works. So that's really easy to do a custom certificate, custom DNS, and get back to your Lambda function. So just checking the time. I'm going to do an IAM policy because I think that's really powerful. So let's go back to the dashboard, and we want to go to the service, and we click on the service. And if we scroll down, we've got these different tabs at the bottom. So I can go in and update the routing. We were talking a little bit about the routing. So if I did create a different service and I wanted to do, oops, sorry. I could go here and I could add a listener or delete listeners and edit them and put paths in and all that good stuff. So I could go in, it's not just during the setup, I can go in and change these things. Next option over, we've got access, and we scroll down and no policy defined. So if we go to edit settings, we could have done this during the setup, but we didn't. There's a couple of policies here that we could put in, pre-made ones, simple ones, and it's a not equals anonymous. So this is you just have to be logged in order to be able to access. We're not going to use that. We're going to use one that's a little bit more detailed that I have to paste in. Okay, so I've pasted this in, but my on isn't going to be correct. So I'm going to save this, and then I'm just going to grab the correct on. So here's the correct one at the top of the screen. And I'm going to go back in and just edit that. And then save. And it just takes a couple of seconds for it to propagate, but we'll go and give it a try. So yeah, it's already propagated. So now, when I'm not passing in the credentials or information, I'm getting denied. Here we go. Let's do this. You can see here that I'm using the role where I've assumed the role of VPC admin, which might attached to the EC2 instance. And then if I go back and have a look at my VPC Lattice, and we'll just have a look at the policy that we put on. Let's go to edit settings because we'll have it in color. So we see the principal, and there's the VPC admin that I've assumed the identity. So this should work for us. We've explicitly called out the resource through the on, and we've got an action of VPC Lattice invoke, which means that we're allowed to do it. But then we've also added a condition string here with the get condition. So we have to use get method in order for it to work. Now, let's go back and clear the screen. But the next thing we need to do is we need to make sure that we can pass in the credentials that we require. And I'm going to paste in some commands here. If you're looking for these commands, I did an IAM YouTube and I put them in the comments. So if anybody's looking for these commands, they're pretty easy. Just search VPC Lattice on YouTube, and
you're basically just pulling out the session token, access key, and secret access key from the local endpoint.
Mm-hmm. Yeah, and we're gonna do exactly the same command, but now we just need to pass those in. And again, I'm going to do a nice copy and paste. Okay, and then you see here the slash health. Yeah.
So there is one thing on the screen that Tim just showed that I just want to point out, and that's that last header, the unsigned payload, because that tripped me up for a little while when I was working with this. The way VPC Lattice works today is that the signature v4 signer, when you use IAM off, it doesn't sign the payload, it signs everything else. But that's not the way the SDK, AWS SDK or a lot of the signing libraries work. So in Node, you can actually just inject that header in the Bodo, with the Bodo library, the signer. There is a little toggle switch that you can trigger, but basically you're just going to get access denied if you're signing the payload because the signatures won't match. So unsigned payload. Julian dropped a link to the blog post that we did on this topic, but it actually includes that little snippet in Node in case you need a reminder.
And I know we're starting to get close to time, but I'm just going to do exactly the same thing, but I'm doing a post. So I'm defining that I'm going to send in a post, and I've got here an exception is not authorized to perform resource because no service-based policy allows blah, 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 blah action. So anyway, because we had that method defined as get, and we're trying to do a post, we've got a denied. Whereas before, when we did it without that post, it worked perfectly. So you can
we're basically also providing another way to think about it. In this example, is providing an HTTPS endpoint to a Lambda function that isn't using API gateway, whether it's using REST or HTTP APIs, nor is it even using function URLs. You're actually targeting the network construct of that, and then it is just invoking a Lambda function in the background. And second to that, is there anything different you need to do in a Lambda function in terms of the input payload that is different between API gateway or Lattice or ALBs? How should people think about that?
Yeah, so the payload is different from VPC Lattice. We can grab the doc, but the payload is different than API gateway. You'll see a lot of the same information in there, like the raw path, the headers, the query string, but it is a different payload.
Okay. But yeah, I do like being able to use IAM policies to restrict the get and the post, because you can have a your more generic Lambda function, maybe doing a get and a post or that kind of thing, and you can use in a way go back and have more of the security within the networking part of it.
Yeah, it's a nice way to centralize things, and again, like it very much simplifies. If I'm calling a Kubernetes service or a Lambda service or whatever, it just doesn't matter. But it makes it a lot easier to manage.
And And then the only other thing really that's interesting, I'm not going to go through the whole process here, but I just want to show you that if we want to use the shares, if you want to create a share and you basically scroll down or type it out, you can share a whole VPC Lattice service network with a remote account or just individual services. And if you share an individual service, the remote side has to create their own service network and attach those services to the service network that they want to at the far side. But if you're sharing a lot of services with another account and you dynamically change them, you can just share a service network and publish and take, change which services are in that service network as you need. So that's pretty cool too.
Excellent, I like it. Just sort of wrapping up as our time is coming to an end. Nipun, do you have anything to add?
Just one more point I wanted to just quickly make was, Josh, any thoughts on these custom domains for private APIs? I know we can do that. There are some hacks that you could do with API gateways, but with VPC Lattice also supporting that, any thoughts there?
Yeah, we have customers asking us all the time, how do I build private domain names or private APIs? To me, this is a really straightforward way to enable that these days. I mean, Tim showed how quick and easy it is to go create a custom domain name, associate a cert if you have a domain with it, and then start using it.
And one thing as well, and I'm just showing you this, that let me go from full screen. If I take the domain name for the health and I just go to my terminal window and I do a dig on it, I can type, and I know that that's way too small, so let's see if I can make that bigger.
But you've got the link local address, yeah.
Yeah, so this has actually resolved to something different, but the bit I want to make clear is that this resolves globally, that you can access it anywhere, and it gives you one of these link locals, which is useless to anybody. It can be different in the VPC. Actually, let's just dig that in the VPC and see if it's .64. I think it's going to be .0, but we'll see.
Has this been more networking than we've ever had in Serverless Office Hours before, Julian?
I think we're winning the award for more networking, and I love it, because, as I said in the beginning, we abstract a lot of the networking away from serverless, which is great. But the reality is there's a lot of networking still to do to connect with other kind of things. And I love that this makes it easier. And, just a quick thing, a lot of people think, Lambda, connecting Lambda functions to a VPC. Shouldn't I? If you need to connect to Lambda functions to VPC, absolutely no reason not to. There are no cold start penalties. It works really well, just making sure you've got multiple availability zones. But also one thing to bear in mind, connecting Lambda functions to a VPC, if you're only doing it for, end quotes, get them on the screen, for security reasons, all internal AWS traffic's over the global backbone. It's not necessarily going to be inherently more secure. It's not over the public internet. But if you want VPC flow logs, if you want egress control, and there's another one which slips my mind, which is always useful, VPC flow logs, egress control, something else. Anyway, VPCs and Lambda work super well. And now here's an even easier way that you can have all the benefits of that VPC kind of stuff with the monitoring, and I haven't got time to go through it, monitoring, observability, and all that built in, but not have to deal with a lot of those VPC constructs. Thank you so much, all of you. Really appreciate spending the time with us today. Next week, we've got AppSync, all about serverless GraphQL. But yeah, really appreciate the time. Josh, Nipun, Tim, appreciate all the networking information we've had today. Yeah, thanks so much. The links in the show notes about the blog post. There's also a serverless LAN pattern if you want to dive into some of the code to make some of this work. Thank you very much, and see you same time, same place next week. Tim, Nipun, and Josh, appreciate